2.3, and this is the proof of the quotient rule. And so in this proof of the quotient rule, we want to take the derivative of f of x over g of x with respect to x, and that is our limit as h goes to 0 of f of x plus h over g of x plus h minus f of x over g of x, and that's all over h. Well, first thing I guess I need to do is get a common denominator to add that numerator together. So this is the limit as h goes to 0 of f of x plus h times g of x minus f of x times g of x plus h. So in getting that common denominator, and then I have g of x times g of x plus h, and that is all over h. Now I invert and multiply, and actually I'm going to just kind of remove the two g's under there over to the side. So there, now I still have the limit of the one, x plus h, g of x plus h. So I'm just going to write this for now as 1 over g of x, g of x plus h, like that. And then this other part, so I have that part, and then the f of x plus h g of x minus f of x g of x plus h all over h. And so now I guess I'm going to go ahead and do these limits separately. So I'll, the limit of this thing as h goes to 0 is just g of x quantity squared on the bottom, so 1 over that, and then I'll have the limit of this part here. So I'm going to write 1 over g of x squared, and then times the limit as h goes to 0. Now, for this part over here, I'm going to do essentially the same trick I did with the product rule. Is I'm going to add 0, and so if I do f of x plus h g of x, and I subtract out f of x g of x all over h, and let's see, so we'll need some big square brackets, and then I'm going to add to that the same term, so plus, and let's see, so I'm going to go ahead and separate the limits as well through the addition rule, and so when I added that in, I have the f of x g of x, and then minus f of x g of x plus h all over h, and we have that, closing that off there. Okay, so that's equal to 1 over g of x squared times, now, here again in the top, we factor out that g of x, and we're just left with the derivative. Okay, so we have our f prime of x times g of x, so that's that term. Now this term, the second term, notice I can factor out the f of x, but then notice I have the g of x minus the g of x plus h. In other words, I've got the negative of the derivative, and so there I have my minus f of x times g prime of x. Okay, so that's where that minus sign comes from, is that my g of x and my g of x plus h, those two things, were reversed on that minus sign in there, and so I have negative of the derivative. And so there we go. There's the quotient rule, and that's our proof that that's actually how we take derivatives of quotients.